Hello and welcome. For the maths, today a fairly straightforward integral. Well, not straightforward, but it's just integration by parts, and I'm going to do it in my own way because I like to show some kind of like bizarre techniques sometimes when it comes to parts. So this is now the integral, no limits, 12x squared. Standard integration by parts does work in just as efficiently as what you're going to do. And I'm not doing anything different but integration by parts, but I do it in a kind of like my own way, because that's how I taught myself integration by parts. A little story behind it. Because I'm self-taught at A level, I could not follow the integration by parts and the formula and all this kind of thing that from the textbook I was using. So at the time, my differentiation was quite good. So I was doing integration by parts, but differentiating. And by differentiating, essentially, I didn't realize at the time I'm actually doing integration by parts. So I look at this quantity here and say, you know what? Something which looks like that comes from differentiating, possibly, the product, and because I've got 12x squared, I might as well just write it as something x cubed, because I want to differentiate the first thing with a 4 at the front, times the arctan of x. So if I differentiate 4x cubed arctan x, product rule, I will definitely get something which looks like that. Of course, I will get other bits. So let's see what happens. 12x squared, differentiate the first thing, arctan of x, but now got the annoying extra bit in there, which of course is leave the 4x cubed alone. And of course, if we differentiate the arctan of x, it's simply 1 over 1 plus x squared. And now I don't have an antiderivative. Or have I? Well, I can integrate each of these three expressions with respect to x, dx, and d by dx of that is, of course, will open up this integral. So what I'm getting now, looking at the next line, I'm going to get 4x cubed arctan of x, because differentiating this with respect to x and then integrating with respect to x opens up the integrand. Pardon me, equal to 12x squared, and that was the rationale of what I've just done, which of course now my integral is appearing up there. But of course I have another integral to do here, and so long as I can integrate that, I get an expression for this which I can move to the other side, to the left, and I'm done. So the question is now, how do I integrate that? That's improper. So what I could do with this particular quantity, what I could do is I could split, pull that x, the 4 to the front, and the x cubed, I can write it as x squared plus 1. That's my x cubed plus x minus x over 1 plus x squared. Dux. 4x cubed. And this is practically done now, because I'm going to get more arctans there, I think. Just looking at it. No, it's not an arctan. Is that divided by that is going to be, of course, a plus. This cancels that, so it's going to be a 4x. I'm writing the 4 inside the integral so I can see it, so don't forget. That's divided by that, and then I got a minus 4x over 1 plus x squared, and this is a log. Bottom differentiates to the top. 4x cubed arctan of x is 12x squared dx plus we got a 4x squared for this particular one. Oh, not 4x squared, what am I saying? I'm ashamed, sorry. Integrating that now, 2x squared, and that is of course a minus, we have a 2 log, we don't really need mods because that's always positive, minus 2 log of 1 plus x squared, and the plus c, I'm going to write it. So I'm going to put this bit on the left. Actually, I've got room to put it up there. So this, in fact, this is my answer that I'm writing up here. So this integral that I'm trying to find is equal to, oh, for crying out loud, can't keep my hand straight. 4 x cubed. And you got to remember my handwriting used to be quite desirable. I don't know what's happened to me. Minus 2x squared, so I subtract that to the left, plus 2 lots of the log of 1 plus x squared. And since everything has now finished, we can put a plus c. And the question, of course, that I'm asking again is, was there, I didn't use integration by parts, did I? Well, the answer is I did. It's just I've done it from first principles, essentially. And I prefer sometimes doing this than just doing the little tables, a little tabular thing on the side. It's fine. It's a matter of personal choice. There's nothing amazing about what I've done. I've just done this to actually explain a little bit without using a formula, with using a particular function, what integration by parts is. Okay, I'm signing out. This video is getting too long. I'll see you real soon. Bye for now.